Hello guys, so welcome back to the channel and welcome back to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. Today is day 54. This is the second day on the course Introduction to Seaborn in Python. You know, Seaborn is the Python library that you use to make powerful and attractive data visualization in Python. We can use Seaborn to create a variety of plots, including scatter plots, count plots, bar plots, and box plots, and how you can customize. So we're going to be learning how we can also customize our visualization using the Seaborn or Python library. So without further ado, let's continue from where we stopped on day 53. I'm just going to start sharing my screen real quick. Just a second there. So all the data set that we'll be using in this data visualization with Seaborn will be linked under the YouTube description. So you can just download the data set and practice along with me. So this was where we stopped on the previous live stream. So we've covered introduction to Seaborn, where we actually looked at the introduction to Seaborn. We look at making a scatter plot with lists. We also use pandas in combination with Seaborn. We did some different visualization over there. So we're just going to continue from visualizing two quantitative variables. So in this chapter, you create and customize plots that visualize the relationship between two quantitative variables. To do this, you will use scatter plot and line plot to explore how the level of air pollution in a city changes over the course of a day and how horsepower relates to fuel efficiency in cars. You will also see another big advantage of using Seaborn. In Seaborn, the ability to easily create subplots in a single figure. So let's see what we need to learn in this lesson today. I'll just go ahead and launch my Jupyter notebook file that we've been using so far for this lesson. So you have access to all these data sets. Just follow the link under the YouTube description so you can easily download all these data sets for practice also. So this was chapter one. We've completed chapter one. So I'm definitely going to be starting with chapter two today. So this was all we did on chapter one lesson. This chapter one, introduction to Seaborn. This was all we did from that chapter. Just did a couple of visualization and a couple of box plots. This is a count plot rather, or box plots. And this was the data we used, the data containing the countries of the world. This is just a couple of columns here. So this is giving information about different countries in the world, their population, their GDP, death rates, agriculture, industry, and services. So in this lesson, I will probably be using one of the data sets, which is this car data set here. So let's continue.
Many questions in data science are centered around describing the relationship between two quantitative variables. Seaborn calls plots that visualize this relationship relational plots. So far, we've seen several examples of questions about the relationship between two quantitative variables, and we answered them with scatter plots. These examples include: do taller people tend to weigh more? What's the relationship between the number of absences a student has and their final grade? And how does a country's GDP relate to the percent of the population that can read and write? Because they look at the relationship between two quantitative variables, these scatter plots are all considered relational plots. While looking at a relationship between two variables at a high level is often informative, sometimes we suspect that the relationship may be different within certain subgroups. In the last chapter, we started to look at subgroups by using the hue parameter to visualize each subgroup using a different color on the same plot. In this lesson, we'll try out a different method, creating a separate plot per subgroup. To do this, we're going to introduce a new Seaborn function, railplot. Railplot stands for relational plot and enables you to visualize the relationship between two quantitative variables using either scatter plots or line plots. You've already seen scatter plots, and you'll learn about line plots later in this chapter. Using railplot gives us a big advantage, the ability to create subplots in a single figure. Because of this advantage, we'll be using railplot instead of scatterplot for the rest of the course. Let's return to our scatterplot of total bill versus tip amount from the tips dataset. On the left, we see how to create a scatterplot with the scatterplot function. To make it with railplot instead, we change the function name to railplot and use the kind parameter to specify what kind of relational plot to use, scatterplot or line plot. In this case, we'll set kind equal to the word scatter. By setting call equal to smoker, we get a separate scatter plot for smokers and non-smokers, arranged horizontally in columns. If you want to arrange these vertically in rows instead, you can use the row parameter instead of call. It is possible to use both call and row at the same time. Here we set call equal to smoking status and row equal to the time of day, lunch, or dinner. Now we have a subplot for each combination of these two categorical variables. As another example, let's look at subgroups based on the day of the week. There are 4 subplots here, which can be a lot to show in a single row. To address this, you can use the call wrap parameter to specify how many subplots you want per row. Here, we set call wrap equal to 2 plots per row. We can also change the order of the subplots by using the call order and row order parameters and giving it a list of ordered values. Alright, now it's time to practice what we've learned and create some relational plots.
Hey, interesting. Let's say we can recreate relational plots in my Jupyter notebook here. Since we are on chapter 2, I'm just going to create a new Jupyter notebook file right here. Let's create a new file here. So I'm going to call this visualizing two quantitative variables. Okay. Into visualizing two quantitative variables. So this is going to be chapter 2. I will just leave it like that. So I'm going to import all my libraries right here. So I run this code. This should import all these libraries for me. And we've actually worked with all these libraries since we started this Python learning journey, all the way from day 1. So the next thing we need to do is to connect to a data set that I'll be using in this instance here. So I don't know the data set we'll be connecting to for this chapter 2. But let's read the instruction first. So it says, we've seen in prior exercises that students with more absence tend to have lower final grades. Does this relationship hold regardless of each how much time students study each week? To answer this, we will look at the relationship between the number of absence that a student has in school and their final grade in the course, creating separate subplots based on each student's weekly study time. Seaborn has been imported as SNS, maths plus lib.py plot has been imported as PLT. Modify the code to use replot instead of scatter plots. So we need to point to the student data. Let's see if I have access to the student data right here. Student alcohol consumption. Ooh. So this is student alcohol consumption. Young people survey response. So let's say the data set we need to point to here. So student alcohol consumption. Is that it? Okay, let's see how this goes. Oh, I didn't get the spelling. I'm missing an O there. Let's call it students. Students. Let's call them students and see what we have here. Oh, so this is their study time. Student.head. This has nothing to do with alcohol consumption. So this is 30 columns of data. Ooh. But let's follow the instruction here and see. It says modify the code to use replots instead of scatter plots. So it's just sns.replots. Let's run the code and see. Uh-oh. Real plots. So it's going to be real plots. Oh, voila. Let's submit and see. Oh, I didn't change the data to kind. I need to mention the kind function here. Then comma. The kind is going to be equal to so we need to mention the kind we want to use here. It's going to be scatter. Let's run the code again. So we got the same results though. So modify the code to create one scatter plot for each level of the variable study time. Arrange in columns. Okay. We have our SNS.replot here. Absence, our x-axis, y-axis. Then our data is student data. The kind is scatter plots. Then we need to add one more line of code. It's going to be modify the code to create one scatter plot for each level of the variable study time. Our study time is going to be arranged in columns. Call is going to be study time. We should have two variables we can see. Study time varies based on the information we have here. See, we have different study time here. Oh, that is a little bit smaller. Absence, absence, absence. But the study time is kind of different. So you can see that pretty well there. Let me widen it a little bit. Yeah, because we have to do a study time. This is less greater than 10 hours. But let's submit and move on and see. Now let's see the last line of instruction here. It says adapt your code to create one scatter plot for each level of a student weekly study time. This time arrange in rows. Okay, so Just change this one to rows. This line of code to row. So it's going to be stacked above each other, just like that. You can see. Study time 5 to 10 hours, less than 2 hours, greater than 10 hours. You can see the different absence we have there in that graph. Great job. Because these subplots had a large range of x values, it's easier to read them arranged in rows instead of columns. Okay, interesting. I hope you could see that a little bit clearly. There's this line of code. You see, so this is our x-axis. So if you're using the replot instead of the scatter plot or line of code, you're going to have different view for your variables that you're visualizing based on the category you've broken them down by. Okay, creating two-factor subplots. Let's see what we need to create a two-factor subplots. So let's continue looking at the student data set of students in secondary school. Here, we want to answer the following question. Does the student first semester grade G1 tend to correlate with their final grade G3? There are many aspects of a student life that will result in a higher or lower final grade in class. For example, some students receive extra educational support from their school or school sub or from their family, from sub, which could result in higher grades. Let's try to control for these two factors by creating subplots based on whether the students received extra educational support from their school or family. So use the plot to create a scatter plot with G1 on the x-axis and G3 on the y-axis using the student data frame. So SNS dot real plots, open brackets. So on the x-axis, we'll be having the G3 variable. On the y-axis, we'll be having the G1. Oh, G1 is supposed to be on the x-axis. So the one on the x-axis, G3 on the y-axis. So our data set is going to be data we'll be pointing to is the student data. So okay, and this is starter. Let's run the code and see. Okay, we are missing. What's the error we're having here? G1. I'm referencing G1 correctly now. So it's not picking my G1. Why? G1. So G1 exists in my data frame though. Oh, okay. Let me add my kind. Because I add the kind of plot I want. Kind is going to be scatter. Scatter. Let's run the code again. Uh-oh. I see having the same error. Students data. Real RELPLOT. G1 versus G3. Use real plot to create a scatter plot with G1 on the x-axis and G3 on the y-axis using the student data frame. Wow, this is quite funny though. Kind scatter. Okay, let's copy this line of code here to save time. And see that we have same result though. SNS replot G1, G3 student data. Okay, let me delete this line of code then. Probably because I'm mapping my student data. Oh, I'm mapping my data in quotes. That was my mistake there. Sorry about that. Let's submit the answer. So create a column subplot based on whether the student receives support from the school or that so that yes comes before no. Okay, we want to create a subplot now, two different plots. So I'm just going to go to my kind line of code and say core going to be school sub, but our call is going to be a little bit different. So call order call underscore order is going to be ordered so that yes comes before no. So it's going to be yes, yes, then this is going to be no, yes, no. So let's run the code and see what we have here. What I can see. So these are those that receive scholarship and those that did not receive scholarship. You can see the school sub yes, school sub no. Look at their grades G1 versus G3. Interesting. So let's continue. So this is our line of code giving us this information here. Student data, SNS replots, G1 versus G3 variable. The student data, the kind is scatter plots. We want to see the variable by column. Then the order is either yes or no. Yes, no. Now it says add row subplot based on whether the students receive support from the family. Order so that yes comes before no. This will result in subplot based on two factors. So you can add the row subplot again. Wow. Okay. Let's see if you can do that. So we have row. Row is going to be farm sub. There's a family support. Then by this we have we are going to have row order. Row underscore order is going to be same way, yes or no. So I'm just going to copy this line of code and paste this. Let's run this. And voila, see what we have here. Let me see if I can make this a little bit easy to visualize. Uh-oh, not really though. I'm trying to make this easy to see. See manageable. You can see this is the thumbs up. So this is the visualization. We have two different variables there. If I switch off my circular camera a little bit there, to see what we have here. You can see the school support, scholarship, and family support above here. You can see the yes and no variable, yes and no subgroup rather. Let's submit and see. Good. So we nailed it. So fantastic. It looks like the first semester grade does correlate with the final grade, regardless of what kind of support the student receives. Oh, this is better view now. You can see the family supports, family supports. Okay, this is family support, school support, yes. Family support, school support, no. The family support, no. School support, yes. The family support, no. School support, no. You can see the variables, the grade difference are different based on whether a kind of support the student received. Interesting. G1, G1, G3, G3. See the way the grade started off in G1, it rises up in G3. Same thing here. Let's go. Oh, ignore this. I've been learning for a couple of days now of the camera. So let's see customizing scatter plot. Let's see how we can customize our scatter plot a little bit better today. Customizing scatter plot, changing the size of scatter plot points, changing the style of scatter plot points, introduction to line plots. Okay, maybe we should stop here today and see if we can continue this tomorrow, day 55. All right, so we've covered a couple of lessons today. We learned how to create subplots with columns and rows and creating two-factor subplots. So tomorrow we are going to continue from customizing scatter plots. Then we move on to more lessons. Then we move on to more lessons. Or maybe we should just do a little bit of lesson today. That's what we have here. That's what we have here. Or the sadness is that I wasn't able to practice this in my Jupyter notebook here. And I don't like that. I'm supposed to be able to practice that in my Jupyter notebook here. But we have the line of code here. So no matter what we do, we are fine. Okay, so let's do a little bit of lesson again. Let's see if we can cover this customizing scatter plots. Let's see.
So far, we've only scratched the surface of what we're able to do with scatter plots in Seaborn. As a reminder, scatter plots are a great tool for visualizing the relationship between two quantitative variables. We've seen a few ways to add more information to them as well, by creating subplots or plotting subgroups with different colored points. In addition to these, Seaborn allows you to add more information to scatter plots by varying the size, the style, and the transparency of the points. All of these options can be used in both the scatterplot and relplot functions, but we'll continue to use relplot for the rest of the course since it's more flexible and allows us to create subplots. For the rest of the lesson, we'll use the tips dataset to learn how to use each customization and cover best practices for deciding which customizations to use. The first customization we'll talk about is point size. Here, we're creating a scatter plot of total bill versus tip amount. We want each point on the scatter plot to be sized based on the number of people in the group, with larger groups having bigger points on the plot. To do this, we'll set the size parameter equal to the variable name size from our dataset. As this example demonstrates, varying point size is best used if the variable is either a quantitative variable or a categorical variable that represents different levels of something, like small, medium, and large. This plot is a bit hard to read because all of the points are of the same color. We can make it easier to read by using the size parameter in combination with the hue parameter. To do this, set hue equal to the variable name size. Notice that because size is a quantitative variable, Seaborn will automatically color the points different shades of the same color instead of different colors per category value like we saw in previous plots. Now, larger groups have both larger and darker points, which provides better contrast and makes the plot easier to read. The next customization we'll look at is the point style. Setting the style parameter to a variable name will use different point styles for each value of the variable. Here's a scatter plot we've seen before, where we use hue to create different colored points based on smoking status. Setting style equal to smoker allows us to better distinguish these groups by plotting smokers with a different point style in addition to a different color. The last customization we'll look at is point transparency. Setting the alpha parameter to a value between 0 and 1 will vary the transparency of the points in the plot, with 0 being completely transparent and 1 being completely non-transparent. Here, we've set alpha equal to 0.4. This customization can be useful when you have many overlapping points on the scatter plot, so you can see which areas of the plot have more or less observations. This is just the beginning of what you can do to customize your Seaborn scatter plots. Make sure to check out the Seaborn documentation for more options, like specifying specific sizes or point styles to use in your plots. For now, let's practice what we've learned.
Interesting. So you can actually customize different view of your Seaborn parameter. Well, let's see the data set we'll be using here. Oh, great. So in this exercise, we explore Seaborn's MPG dataset. Fantastic. I actually have access to the dataset here. So I'm just going to point to the dataset mpg.csv. So I will continue mpg. I'm going to call this mpg. So if I change this to mpg, well, let's look at the data set we have here. MPG cylinder, displacement, horsepower, weight, acceleration, model year. So this is giving us information about different cars. If I look at, let me let me just clear the dot head and see number of data we have here. Over 300 rows of data for this. So as it is, we're going to continue from here on day 55 live stream. Okay. We're going to be using this MPD data set to visualize and answer this key question here. All right, so let's stop here for today and take a break. I'll see you tomorrow, day 54, 55 rather. All right, so that'll be the end of the live stream for today. So if you find value in this learning journey of Python with me, do well to support this channel by giving the video a thumbs up, hit that subscribe button, and I'll see you on the next video on the channel. Have a wonderful rest of the day. Let's get